The bridge structures, the alignment through this section, the terrain means that we can't use a conventional cut-to-fill type earthwork strategy, and we've adopted a large number of bridge structures to try and minimise our footprint and therefore our impact on the environment. Unfortunately, bridge structures don't tolerate any movement, and the collapse or the potential collapse of mine voids could result in vertical movements and horizontal movements, which the bridge structures can't tolerate. So our aim or our objective is to try and limit or mitigate that settlement, and that's why we're filling those voids.
The coal mines are being filled with what's basically a very low strength concrete. We don't need a high strength material, we just need to fill the void, and we make what we call a grout, and that means a flowable liquid that's about the consistency of cream, and that's made of water, fly ash and cement. We pump it into the ground as a liquid, it then hardens in about 2 hours, and then over the next month will gain its full strength. It is, to be honest, a huge drilling and grouting project, the biggest one that I've been involved in 20 years, and grout is approximately 200,000 cubic meters, so that's 250,000 tons of grout.
Here on the second part of the Hunter Expressway, we have 2 areas of mine subsidence. This is due to basically old faults in the ground. That's coal seam has popped up in 2 areas. The 2 areas are Kurri Kurri and Greater. So currently, to this date, we've grouted up all the workings at Greater, and we are here on site at Kurri Kurri, and we are filling up the mine voids between the ground surface and a depth of 50 metres, basically so we can ensure the structural stability of the Hunter Expressway in this second section. The drilling process begins with the drill rig set up over a certain spot, and the drill rig goes to a depth of 50 metres, after which time they place a PVC pipe into the hole to a depth of approximately 10 metres so that the hole doesn't collapse, and that's what we can see behind us here, is all the PVC pipes in the ground. After that point, the grouting crew can come up with a tremie pipe, and then they can put that into the PVC pipe and put grout into the ground down the hole.
Coal is mined in the Hunter Valley, and one of the main uses for the coal in the Hunter Valley is to make electricity in electricity power stations. When the coal is burnt, there's ash left over as a waste product from the coal. Here we use that waste ash product to fill the mines. So our grout is 70% ash, 5% cement or thereabouts, and the remainder is water. So the grout is basically made of the waste product that's created by taking coal out of the ground, burning it in the power station. We take that waste and then put it back into the ground to fill and stabilise the mines.
The batch plant that's behind us, or in fact 2 batch plants, we've got 2 on the site, both identical. They're, I guess, been basic about it, they're just huge food mixers or industrial mixers. So they take 2 dry powders and water, mix them together, and that creates our grout, this liquid that we pump into the mines that hardens over the next 2 hours or so. So the grout comes out of the batch plant into a holding tank, and from there into the pumps. We've got various pipelines that snake around the site. We pump it across the site, we pump it over the F3, under one of the F3 link roads, through the construction site, through the bush, but basically comes out of the batch plant and we pump it direct from the plant across the site down into the mine.
Deciding where we have to do the mine fill work requires us to get hold of the old mine plans. Those are about 100 years old, drawn on linen, and you can imagine bits of linen that are 100 years old take a lot of interpretation.
We knew generally where the areas were. One of the major challenges we faced though is the fact that none of the mine workings actually link up to where we drill. So if you drill in a particular spot and you expect to hit a shaft or a void, you don't actually hit it. And so that's probably one of the major challenges we've faced here, is not knowing exactly where they are and having to come in here and work all that out for ourselves. We use the drill rig you can see in the background here to nullify where the extents of all the workings were. So at the start of the job, we had the drill rig in here before the grout plant was set up, and that drilled around the area to work out where the edge of the workings were and where we needed to fill up from.
But once we have our best understanding of the mine fill work, or the mines that have to be filled, and we understand what bridges we have to protect, we then drill holes into the mine, drop cameras down the mine. These are remote control cameras, usually on umbilical cables, 100, 150 meters long.
And those cameras allow us to look into the old mine. So we can see the voids, we can see the roof, we can see the pit props, the old railway lines, we can see if the mine is collapsed or starting to collapse, and all of that information helps us alter the grout mixes for something that's higher flow or for something that's a bit stiffer, and they allow us to optimize the grouting process and also to measure what we're doing. So rather than simply stopping pumping when we can't pump anymore, the cameras allow us to watch the filling operation, the cameras tell us when it's full, and that allows us to be certain over the filling.
One of the main innovative techniques here is using directional drilling and incline drilling to reach the mines. Because the available work area at surface is very small, it's about 10% of the area underground we want to fill. We need a way of getting from that small 10% at surface down to the rest of the mine underground. And we do that basically by drilling inclined holes. Here, what's maybe really different about that is we've got a huge amount of inclined drilling to do. It needs to be fast, it needs to be accurate, it needs to be right first time. And once we've drilled it, we need to measure where it's ended up so that we know we're in the right place. So the drilling equipment we use, 5 of those rigs are the only kind of those rigs in Australia. So we're using fairly high-tech drilling equipment. Then the tools that we use for running the downhole surveys have been specially adapted by our team tech, as we call it. So the technicians that develop the downhole survey tools have modified them for this job. And I like to think we have the best downhole mine footage that has been obtained. It's certainly the best that I've ever seen on any project. So the limited access drives us to do lots of innovation, and it's, as a project manager or as an engineer, it's great.
The job has been genuinely one of the most enjoyable I've been on. The overall project, the alliance that's building the freeway, is a great place to work. A great team, people who do what they say they're going to do. And in the minefield team, without a doubt, it's just a great place to be. We had a huge job to do. We've done it. We know we've done it right. We've done it on time. There's a lot of satisfaction in that. And the way that the rest of the team building the rest of the road works around us makes it a great job.